Welcome in your physics studies. Today we start with a topic known as work, energy, and power. We start with the term work. Work sometimes always is called the work done. Work done by definition it says that the product is a product of force and a perpendicular distance. But or you can state that you can define that is a product of force and distance moved in the direction of the force, in the direction of the force. Okay. When you start a definition of work done, always we start from a definition and followed by the SI unity. The SI unity of work done is Newton meter due to joule. And the Newton meter, where is it come from? The rates come from in mathematically of work done. In mathematically say that work done is equal to force times the distance moved. That is the times is a term which is state of the product. It means that times, and then we state of that is mathematically of this. But you recall about force. Force by definition, you say that is the push or pull of a body, or you can state that is a push or pull experienced on a body. You say that or in the push or pull which experienced by a body. That is the definition of force. And finally we say that the SI unity of force is Newton. And the term Newton, that is the name of scientifically of father of physics of the Sir Isaac Newton. Let's discover force, and then finally we give the definition. The SI unity of force is Newton. That is, in mathematically we say that in mathematically force it says that force is equal to mass, that is mass times gravity. That is the terms which describe about a force. That's the definition of force here. And if a nectar says that defines the term force, you don't end with a definition only. You stand with a definition, and then is the SI unity, and then if you know, write it mathematically. That is the route of acquiring marks is come and then you finally recall that a work says that is a force. Definition of the force that is, and the distance, that is a distance is a meter. The rest tell us of somebody's or the student which describe or defined about the term distance. And when it tells us of the term distance is the length from one point to another point, and the SI unit of distance, the SI unit of distance is meter. Is meter. And all in all, we say that is the definition of work done, and then finally we have that where is a Newton meter is found. That it's a third of this. It's continuous with another chapter of force, and we end with the term distance, and finally we go on with the work. That it's a work is equal to force times distance. If somebody is give you a mass to find a work done, you start that but you say that is from force is equal to mass times gravity, and this gravity, mass times gravity, you carry this, that is work done is equal to force times distance, and the force is here, but I'm carry this is a term of mass times gravity, and then I submit in this, and then we tell us that is a mass times gravity times distance. And if you find a mass, that it's easy to get this. And if you find a work done, that it's give a mass, give the gravity. Always gravity is a constant, and the gravitational force G, this is a constant, is 10 Newton per kilogram, or 9.8 Newton per kilogram. That is a constant, but that is differentiating. You say differentiating mathematically. Differentiate in mathematically about gravitational force, and that is a question. Differentiate in mathematically of a gravitational force, and acceleration due to gravity. Acceleration due to gravity. This answers of this one. Gravitational force is equal to 10 Newton per kilogram. And finally, you can state that is 1080, and the one that it tells of Newton per kilogram. And the acceleration due to gravity, A is tell us that is 10 meter per second square, or you can state that, or you can say that 10.8 meter per second square. There it's a definition. There it's acceleration due to gravity, and there it's In a summary, in a deeply summary, gravitation is applied. That it's a force of attraction. That it's a gravitational force. We say that G is the attractive force of a body toward itself, toward the center, toward the center, toward the center. And then we say that is acceleration. This is applied to a body when you go in upward or vertically and downward. Gravity deals with upward and downward. But acceleration due to gravity, that is moving of a body in the earth's surface, especially horizontally movement, horizontally movement of a body, especially example of a car, example of a human being that it's moving with the acceleration due to gravity. And finally we say that work done is equal to mass times gravity times distance. But density, it says that is mass per unit volume. Is mass per unit volume. And finally we say that the density is equal to mass per volume. And finally we say that this one, I draw these symbols which is show I want to find something which is given for your question, and that is the removal of density. Mass is put in upward and then forward by the density and then forward by the volume. This line drawn horizontally, this is a line of division, divided, and this line is drawn vertically, that is called times. And this is called the definition of this, and that's easy. This is present this, and this is present this. I want to find a mass. Mass is equal to, I put a finger, I put a thumb, and then I find density times volume. Density times volume. That is a simple way of getting the summary of mass. That is putting of this. And that let's see. Remember that we end with the mass is equal to density times the volume. You recall that about the work done is equal to what? Is equal to mass times gravity times distance. There is a value of mass, there is density times volume. I take this density times volume and then I put in a mass. There is of this, there is density times volume, that is put in the mass times gravity remain times distance. If we use a symbol like this, must be you describe what is a symbol represent, especially with things that where W not the woman, that it's a terms of there is a work done. There is a unit of work done, there is terms of this of joule, that is a large unit. And the V not a Veronica, but is called a volume. That volume is meter cubic or centimeter cubic or decimeter cubic or liter, sometimes called millimeter cubic. And this G represent not a Gauden's but gravitational force. Gravitational force, the SI unit is Newton per kilogram. Then it's a constant. Gravitation is a constant, that it's 10 Newton per kg. And let's see, sometimes is called rho. That is a Greek name. Rho. Not the rho. Rho, that is a density. This is representing the density. Remember that density that have two SI unit. The SI unit of density follows by, if we use a kilogram, must be is gone with a meter per cubic or gram per centimeter cubic. Let's see, gram per centimeter cubic and a kilogram per meter cubic. And D, not a diana, that's tolerance of distance. Distance, the SI unit of distance is a meter. Right. If you use a symbol, remember that if you use a symbol in a nectar, must be you translate this symbol into the word of the meaning. Rho is called the density, volume, gravitational force, that's distance, and work done. If you are not translating this and then you put a number to this, that you are failing to answer a physics in your examination room. And I recall that the term, there is some question you're asking, which does not involve the mathematical, this question. You say, why to say the work be done? A student, remember this. If you say why, remove the term why and then paste the term which are remained. That is the answer of this question. Put the finger and then copy all of the word which are forward and remove this one. You say to say the work be done, and then you put a comma. You start with the because, and then because the board is moved from one distance to another, from one distance to another distance. Or you can say that a body, say that the board is moved from one point to another point, to another point. That is a